Let's continue with our JiTickLogic library. Hello everyone, this is Ali Reza. Welcome to the Mentor Code Lab. In previous videos, we had implemented our Blackboard, we had implemented the nodes, and then we had implemented 3 nodes, the start node, the action node, and condition node. In this video, we want to work on sequence node. Now let's talk about sequence. A sequence node will return success only and only when all the sub nodes inside itself, the children, will return success. The moment one node returns failure, the sequence will break its progress and will return failure. If one of the children become a running state, the sequence will not change. It will not add itself as a running node. And that is why when we were implementing our infrastructure, we had a marker interface, and sequence is one of those classes that will implement that marker. Basically, when a child is running, it will not add itself to the tree's running nodes and only set that child as a running node. So in this scenario, when we have this complex tree, let me collect these and move them to the side for time being. Let's say that we are running the second branch. So we ran the first branch, it returned success. That is when the sequence goes for the second branch. Now, forget about selector. It's sufficient that saying that it will run the first branch. Again, it will go for the first node. It will run its first child. And this action node, let's say that it's in a running state. And if it's in a running state, then it will turn running to the not, and not will say that, hey, random selector, we are running. The random selector will say the selector, we are running. The selector will tell the sequence we are running, and the sequence will tell the start node that we are running, and the start node will tell the tree that we are running. However, from this whole branch, only the not node and action node, I think the action node will add itself to the tree as the running node inside the list. So in the next tick, we want to tick the tree, we will run the action node alone. And if the action node is success, it will send success to the not tree, and the not tree will send the success upward. However, the current implementation will not handle that status actually, because let's take a look at what we have so far inside our tree. We see that we just tick the start node. Now a start node will check if we have any node in running nodes, and then it will tick the running nodes and collect the result, and then it will use the aggregation policy to return the result. So in other words, in this scenario, when this action node was running in the second tick, it will not try to pass through all this path to get this node. No, it will directly check this node and tick it, and if it succeeds and it's the only thing that is inside the list, then the start node immediately returns success. So it will bypass this node, it will bypass this node, and this node, and immediately we are optimized to bypass 4 method calls for getting the result. So yes, we are handling that scenario. Okay, anyways, let's add our sequence node, because that's the next node in our list. As always, we want this top part paste, and yes, it is telling that we need to implement the tick. Okay, now the sequence node needs to keep track of the index of the child that is running. So we say private int current child index, we set it to 0, and then we are not adding a constructor because the constructor is just calling the super, and the super is just nothing. I'm a little bit warned here. Why don't we have constructor here? We don't have a black, oh yeah, we have it here. Sorry, I did miss it. So it will just call this guy with the root, blackboard, and everything, okay? However, now we don't have a constructor because the node itself has this parameterless constructor, and when we call this, and it has this blackboard. So if I want to add a node that has a blackboard, then it's just an empty call to the super, okay? And it's something that we can do, and I think it's redundant anyway. So if we want this constructor, you see that we don't want any parameters, okay? And it says it's redundant, okay? Although it's not being called. So let's be consistent. Let's add the constructors that accepts the blackboard, that accepts the supplier in this case. And here we have a constructor that accepts the blackboard and this guy. So in here, I'm not calling the super because as you saw, the parameterless super is just empty. It's doing nothing here. However, if you want to, I suggest that you call the super here because we are not sure if at any time in the future we may want to add anything inside this constructor or not. And if we add anything in the constructor and not calling it here, then we will have a problem. Okay, so let's go for the sequence. In the tick logic, we want to say while the current child index is smaller than children.size, we are not sure how many childs each sequence node has. So each time we stick one and it's successful, we will increase this index. And as long as we are smaller than the list, we know that there are more children in the list, so we move forward. But when we tick the last child and it returns success, and we increase this current child index, then we go out of this while loop. So let's handle that one first. We reset the index to be 0, and finally we return tick status dot success, because if we hit here, it means that we were successfully ticking each and every one of our children until the list is finished. So we achieved our goal for a sequence, and now we can return success. Okay, inside the while loop, we say var child equals to children.get current child index. And if we take a look, the child is actually node t. So let me get that, because I prefer to not use var, and it comes from C# compiler thingy, and I'm not sure if they changed it in C# or not, but using var was not a good practice there. So we want a tick status to be the result of ticking the child. Then we say if the status is equals to not success but failure, this is the condition that is dedicated to sequence. The moment one child returns failed, the sequence will fail. So we say current index is no, not that, equals to 0, and then we return failure. Otherwise, we say if the status equals to running, then we need to say if tree does not equal to null. It shouldn't be null at any time, but it's a sanity check. So we say tree dot add running node, the child. Why am I sending this? Shouldn't send this. Oh, no. Yeah, we say this. Actually, this will not work at all. We will see why in a few minutes. Return tick status running. Now, why did I say this will not work? Let me finish this method first, then we will come back and we talk about it. So increase the index, and that's it. Now, as I said, the sequence node needs to be marked as the iComposite manager. And if we take a look at add running node, it says that start node, add running node, and here we check if the node.getParent instance of iComposite manager return, it will work. Now I understand what's going on here. So here's the thing. What will happen if the action node is actually running, or a condition node? We didn't handle that. Well, in case of condition, we can't be running because we have a supplier of a boolean, so it's just true or false. In case of action node, however, we are accepting a tick status. Okay, so we need to handle it here. So we say tick status equals to that. Then we say if status does not equal to tick status dot running, then return the status. Else, actually, we can do it here. We say return tick status running. Okay, but before returning it, we say if this.tree does not equal to null, then we say tree this.tree dot add running node this. Okay, however, the reason I was struggling with this implementation is that let's take a look at this, and let's say that we have a sequence node and it has an action node. Okay, now what if this action node returns running? By the code we have, it will add the action node to the list, and then the sequence node receives running status and it will return the running, and it will add itself as running node. Okay, so the thing is that the action node sends itself as a running node. Okay, let's keep track. We will fall into the start node here. Now it says that check the parent. Okay, in this case, the parent of action is a sequence, so it will not add the action node. However, when we send in the sequence node as the running state, then it will accept the sequence, and it says that, okay, in the next tick, I need to run the sequence node. The reason that we we are not adding this action node directly is that, let's say in the first tick, this node returns running. Okay, if we directly add this node to the tree, what will happen in the next tick? In the next tick, the node will directly execute itself and return success, and the start node will pass and say, what is the next running node? If we don't have anything, then we succeeded. However, if this node is successful, we were assuming that we need to do something else. And because of that, we will fail this whole logic. So we need to bypass the action node and add the sequence node as running node and directly go for the whole tree again. So we may have some actions that happen before this guy, and we will repeat it until we get to the running node. Now this time it returns successful, and we will continue forward and run the next logic. Okay, so because of this thing, we can't directly say that the child should be added. However, we can't identify it here. Instead, we are identifying it here. And because of that, we need to mark the sequence node as a composite node. And that is the whole reason for that marker here. Now, here is a big question. Let's say that this sequence node has more than just 2 children, okay? Let's say that it has, I don't know, 5 children. What will happen? Why are you not selecting all of them? Okay. What will happen if the second node is actually returning running? And we don't want to tick this first node again, and we want to continue from the second node. In that scenario, we are going back and ticking in the first tick here again with the logic that we have right now. I'm thinking about things that normally are not covered inside behavior tree. I mean, what we have right now as code is even a little bit extended and differed from the normal behavior tree. However, I prefer this one. It's much more flexible. So if we want to track a busy node and we start our tick from there, then we want a private node of t. We call it current child, or we say running child. And here we say if running child does not equal to null, then we want to say current child index equals to the children dot index of the running child. So we will directly start from that index, and we will bypass anything else that we had beforehand. And here we say that when we are running, before the return, we say that running child equals to the child. So we set the busy one, and we are not tracking multiple running nodes here because the sequence will tick one node at a time. The first time we have a running node, then the sequence will return running, and in the next tick it will continue from that running child, and that is making the sequence node actually very robust. It's worth mentioning that normally in Minecraft you should not have a node that returns running. If you have something like that, then your tick logic may be wrong. However, there is a really rare condition that you may have a running node that says go to the target, and I had seen one single example of that inside one mod between all these mods in these years. The only time that I saw this happen was when a block entity was sending a robot somewhere, and on the other hand it was receiving the robot, and it was a flying robot, and this robot needs to go and sit on the target block entity, and in that scenario, only that scenario needs to track its sitting position or its flying target, and only then you will have a node that says running, and this node is responsible of tracking its own distance toward the target and move the entity toward the target. As I said, it's only one mod in the history of Minecraft modding that is doing this, and honestly, I'm not sure even if that would be a proper place for a tick on a block entity, because that robot can be an entity with a goal, and again, it's a totally different story because it will have AI. So normally a block entity wouldn't have a running node. If you have a running node, maybe you need to revisit your logic, make sure that you are doing things exactly the way they should, because 99.9% of the time, a logic inside the behavior tree for a block entity shouldn't return a running state. Anyway, if that happens and you are sure that you are doing something right, then we have covered it. Now in the next video, we will go back and write our selector node. Now the selector node would be really close to sequence node, but this video is taking long, so I want to break each one of these important nodes into their own videos.
If you like these videos, please subscribe to the channel, hit the like button, and turn on that bell so that when I publish a new video, you will get informed. Have fun, everyone. Bye.